All right, looking at number 53, we have temperature of a skillet. A skillet is removed from an oven whose temperature is 450 degrees Fahrenheit and placed in a room whose temperature is 70 degrees Fahrenheit. After 5 minutes, the temperature of the skillet is 400 degrees Fahrenheit. How long will it be until its temperature is 150 degrees Fahrenheit? So we need to use Newton's law of cooling. So we have U of T equals big T plus the original minus T times e to the KT. All right, let's go ahead and write down. We need to know what our T is and what our U of O is. Now, in the problem, it tells us that we're heating the skillet up to 450 degrees. Okay, so that's what our heated amount is going to be. Now, T is going to be the room temperature, and it says it's placed in a room whose temperature is 70 degrees Fahrenheit. All right, so let's go over here and fill in what we know. U of T is equal to big T, which is 70 degrees, plus what we've heated to, which is 450 degrees, minus room temperature, e to the KT. So let's make our generic equation. Now I know 450 minus 70 is 380, e to the KT. Now that I have my generic equation, let's think about what they've told us. We have a ratio here. After 5 minutes, the temperature of the skillet is 400 degrees. So I can use that we have cooled down to 400 degrees and plug it into my equation, and it's going to be after 5 minutes, and I can solve for my K. So to do that, let's go ahead and subtract 70 from both sides, and we'll get 330 is equal to 380 e to the 5K. Now let's divide by 380. So we'll get 33/38 equals e to the 5K. Now to get that down, we're going to take the natural log on both sides. So we have the natural log of 33/38 is equal to, the natural log of e makes the natural log of e go away, and that'll equal our exponent, which we can now divide by 5. So K is approximately, let's go to our trusty calculator, let's clear that out. Let's see, alpha x is equal to the natural log of my fraction, 33/38, all over 5. Okay, and so this is what my K is going to be. And the further out you go, the closer you're going to get to the answers that are in the textbook. Like in the previous problem, we were estimating the date of the prehistoric man. In order to get the 24,765 years that the textbook uses as an answer, you would have to use the entire decimal that you get for K when you do carbon-14 dating. We only went out 8 places, but you would have to use every number that they gave you in your calculator in order to get that 5 at the end. So you're going to be a little off on some instances if you don't use the whole thing. Some of them will round up perfectly, some of them won't. So let's go at least 5 places on this one since we have that 0 in the front. So we've got K equals our negative 0.02821. That's 1, 2, 3, 4, 5. Okay. Oops, that 1 will round up to a 2. Okay, see right here you got 1, 2, 3, 4, 5, and the 5 will round that up to a 2. Okay, so that's going to be my K. So let's go back to our generic equation and let's fill that in with our K value now. So we'll have 70 plus 380 e to my K, which is negative 0.02822 times T. Okay, so now I've got my equation. Let's see what in the world they're asking us to do. So after 5 minutes, the skillet cools to 400. How long will it be until its temperature is 150 degrees Fahrenheit? So that means we want U of T to be 150 degrees. Please excuse my rude children that are talking in the background. Okay, so what we're doing is we're solving for t. We're going to subtract 70 from both sides, which will give us 80 equals 380 e to the negative. And then you're going to divide both sides by 380. Now we know 8/38 will reduce, but it's really just not necessary because we're just going to natural log it out. Okay, so we're going to take the natural log on this side and the natural log on this side. So we'll have the natural log of 8/38 is equal to negative 0.02822t. And remember, the further out you go with this decimal, the more precise your answer is going to be. So let's look at this time right here. So let's plug into our calculator, and we're going to have alpha x. We'll have the natural log of a fraction, which is 8/38, over negative 0.02822. All right, so this is going to be our time. How long will it take? It'll be 55.2 minutes. Now notice what I've got here, 55.21. Notice what they've got here in the textbook, 55.22. And again, that's just using a longer decimal for k. So they're using a longer value. We stopped right here at this one. We rounded it up. If you use the rest of it, then you would probably get exactly the 55.22. So when you see a discrepancy from the answer in my textbook and the answer we're getting, it's simply because I'm not using the entire value for k that's in my calculator. So again, don't let that freak you out. So the time is going to be 55.2 minutes.